And it's an exciting day for space weather because there is a coronal mass ejection headed toward Earth. Can you guess where it came from? All right, let's show you. Right here, see this filament? It's there, and now it's on its way here. You can expect it to arrive. On September 3rd, we'll tell you all about it. And a lot more here at the Smash News Network, least busted name of news. These are 24-hour videos from SDO. That is ionized helium and ionized iron. So, a great example of how you can see an Earth-directed coronal mass ejection without that many sunspots, without major solar flares. These are separate phenomenon. So check out that filament. It's there. Part of it collapsed, and part of it ejected. Huge filament up there by the North Polar region as well. So basically, a further dip in solar activity here overall in terms of things like the radio flux. However, it's about to become some space weather. So exciting stuff going on. Finally, a CME headed toward Earth, and it's almost directly headed toward Earth. So we can expect a significant impact, possibly a KP7 plus from this one. It does look fairly diffuse, though, and a lot of that plasma did collapse. Here's the southern hemisphere just for completeness. You can see a large crown prominence down there. Also, some active regions likely rising over the eastern limb. So let's take a look at sunspots here briefly before we cover everything when it comes to space weather. There is yesterday plus today. That's August 30th and August 31st to date. By the way, the Earth-facing quiet is expiring for that sunspot in the northwest, and its likelihood of solar flares now goes up precipitously. So that's the SDO continuum. Here's the SDO colorized magnetogram. Not a lot of huge changes going on in terms of sunspot activity there, as you can see. And let's briefly take a look at what's going on planet Earth. Mount Abico produced some lightning as it exploded. Great view there of Abico. So let's see what else is erupting here. Consult our daily list here at volcanodiscovery.com. So yeah, Abico has been exploding, producing significant ash plume there. Also some lava bombs. Please don't pole vault the caldera. Sakurajima exploded as well. Flight level unknown. Don't fly your aircraft over Sakurajima. Mount Mayan, volcanic ash cloud unknown there as well. So another hazard zone there. Not exactly sure how big it is. Just don't fly over it. How about that? Karengatang, exploding, flight level 080. It's an 8,000-foot ash plume. Semeru producing a 15,000-foot ash plume. Nevado de Ruiz in Colombia producing a 22,000-foot ash plume. Revenador exploding, flight level 140, a 14,000-foot ash plume. And Sabancaya exploding. 23,000-foot ash plume there from Sabancaya in Peru. Don't pole vault that caldera either. As far as seismic activity goes, there are the past 90 days of earthquakes, and we'll cite quakes in the past 24 that are of a 5 magnitude or greater. So starting out our list here is this 5.0 at New Caledonia. They're north of New Zealand and east of Australia. It was a 5.0 at 13:54 Universal Time yesterday afternoon. And then almost at the same time there, a slightly larger quake, a 5.3 at Vanuatu, just to its north. So 2 quakes there in succession. And then only 20 minutes later, approximately, a 5.3 at Chile. So 1, 2, 3 quick quakes there, all of a 5 magnitude range. Also, King Cove, Alaska there, out in the Aleutian Islands, had a 5.1. That was at 18:59 Universal Time yesterday evening. Santa Cruz region had a 5.1. That was at 21:20 Universal Time, as the seismic unrest continues there in the area of Oceania. So keep in mind, any earthquake can be a foreshock. Maybe those are foreshocks. Don't assume that a large earthquake is the end of the shaken. You never know when an earthquake could be a foreshock, even a large one. So let's get back to space here. It's where the exciting stuff is happening. And by the way, the meteorology forecast is interesting as well. That Hurricane Idalia moved incredibly fast. Here's the past 24 hours from SDO in 304 angstroms. Ionized helium all by itself. And again, here's this filament. It was there. Part of it collapsed, and part of it is headed toward your door. We'll also show the house favorite wavelength. Gotta have it. The 171 angstroms. Just so aesthetically pleasing. These are also 24-hour videos from the Solar Dynamics Observatory. Moving right along here, the 10.7 centimeter radio flux has dipped. It is now at 139 solar flux units. There is the 1 year graph to put it in context for you. The last 1 year of solar cycle 25 depicted there. The black line is the radio flux, the red line is the sunspot number. By the way, if you enjoy the content, don't forget to press that like button. Yeah, press like, it does a thing. Press share, leave us a comment, etc. Yeah, do all the things. Press share, leave a comment. Have you pressed like yet? I can wait. Just press the like button. It's not so hard. Also, don't forget to visit the links in our description. Increase the probability these videos will continue to exist, remain publicly visible, and free for all to view. Space Weather Enthusiast Dashboard not forecasting any geomagnetic storm conditions. We're forecasting one for sometime around midday or later on September 3rd. September 3rd. CME impact is in the forecast. Next, we'll look at Earth's magnetic moment from space for the past 4 hours. There is our geospace magnetosphere movie. And things are calm at the moment. Most of the magnetohydrodynamic pressure depicted in this model is in the magnetotail side, at least for the first half. And now it's starting to equalize there. So a more homogeneous plasma pressure environment. Next, Earth's magnetic moment from the ground. There are the past 4 hours of changes to Earth's B field, geospace delta B. Magnetic flux density is depicted in this imagery, the units of which are nanotesla. So that's the last 4 hours of Earth's magnetic moment from the ground. Geomagnetically calm conditions. By the way, this map is great to use to see where the aurora is likely when we do have geomagnetic storm conditions. And the planetary K index is only at 2 at the moment. We could expect this to get as high as, I would say, as high as 7. Again, it is a pretty diffuse CME, and some of that material did splash back down. So expecting a KP7 to come on September 3rd, sometime after midday. And the current conditions for the solar wind are quite slow here at only 329 kilometers per second. We did see a little bit of a density increase there. That could be the indication of a coronal hole high-speed stream. Currently just under 6 protons per cubic centimeter. It did make it all the way up to about 7.5. So we could see a little increase in the solar wind speed here. It's looking like a pretty weak coronal hole wind stream, though. And let's move on to the GOES magnetometers. A little bit of a dip there in the GOES 18. That's the blue line. And if you're wondering what those N's and M's are, M's and N's, those are noon and midnight local time for the satellites. They are geosynchronous satellites, and they are orbiting in a near equatorial orbit. Next, the top view ecliptic plane field plot. And what's going on with the heliospheric current sheet? Check it out. The North Pole current sheet has just extended. So this is an indication that the northeastern sunspot is going to degrade, or perhaps the southeastern sunspot is going to grow further. So there you can see that North Pole current sheet. We can now expect that to remain for days. So the magnetic environment does have the tendency to change with absolutely no warning. If you did get any, it's probably from our channel. Next, our line of sight field plot. Here the sun's B field is depicted in blue. And let's move to coronal holes. There's our coronal hole line of sight plot. And we do have some magnetic indecision happening over there on the east side. Those coronal holes over there trying to decide if they're north or south pole oriented. Let's take a look at those coronal holes from the SDO. So there's the last image. At the moment, we've got all north pole coronal holes except down here in the southwestern limb. So interestingly enough, you've got north pole coronal holes way down here as well as way up here. This one down here is south pole, and all the rest of these are north pole coronal holes. They're all pretty small, and again, we can expect a huge uptick in coronal holes in the coming 2 years because, frankly, we've seen a shortage of coronal holes throughout solar cycle 25. 211 angstroms is the best wavelength to view coronal holes. That's another 24-hour video from SDO. Next, sunspots. And it's been fairly stable here for sunspots, so no major changes. That's why I say fairly stable. And let's take a look at sunspots here from, once again, the Solar Dynamics Observatory. My favorite telescope. So there you go. There's a 24-hour video featuring 131 angstroms to highlight the active regions and the SDO continuum to show you those dark umbrae of the sunspots. Let's subtract the 131 angstroms. That'll show you any sort of sunspot evolution a little bit better. And we do have a new major flare player here. So this sunspot in the northwest is rapidly becoming the most likely sunspot to produce a large solar flare as it approaches the limb. And here is the SDO magnetogram as well. So not a lot of major changes happening there. CME headed our way. We'll cover it in greater detail here momentarily. First, let's talk cosmic rays. So this is from the Bartol Institute, part of the University of Delaware. And what we're looking at here is the bottom group is cosmic ray flux. That is the Thule Greenland neutron monitor. And then above that, you've got the sunspot number monthly averages. Notice how absolutely inversely proportional those two data sets are. In other words, when you have high cosmic ray flux, you've got low sunspot number. And when you've got a high sunspot number, you've got low cosmic ray flux. So look at how perfectly correlated those are. I would also note that around 1965 or 66 was the second highest cosmic ray flux ever recorded, after around 2009 or so. And that did feature a very small solar cycle 20, the second smallest solar cycle after cycle 24. Solar cycle 25 will be a much stronger cycle than solar cycle 24. In fact, it might even exceed cycle 23. Anyway, let's do a cosmic ray report here. Again, the Bartol Research Institute is a great source to learn about cosmic rays. If you're not familiar with them, they are high-energy particles coming from outside the solar system, and indeed sometimes even outside the galaxy, perhaps. Very hard to determine where they come from because they are affected by magnetic fields. They are mostly hydrogen nuclei traveling at relativistic speeds, meaning a high percentage of light speed. That's very, very fast. And of course, they cause particle showers and all kinds of different effects when they run into stuff. I'll just say that. So here's our cosmic ray report. We're going to show you 7 different neutron monitors here, or 7 different cosmic ray monitors, we'll just say. Apatity neutron monitor showing a small downtick over the past 30 days. Almost flat, but a small downtick at apatity. Barentsburg actually featuring one large spike there, and flat over the past 30 days. So on the 25th, there was a big spike there at Barentsburg, but for the past 30 days, flat. Next, we'll go much farther south to Athens, Greece. Here's the Athens neutron monitor, and that is also flat over the past 30 days. Let's go even farther south to Mexico City. Mexico City, a small uptick, almost flat, but a small uptick over the past 30 days there at Mexico City's Cosmic Ray Observatory. Now we'll go as far south as we can go to Antarctica. And Antarctica, DOMB Antarctica, is showing a slight downtick over the past 30 days. DOMC Antarctica, almost the same graph there, a slight downtick over the past 30 days. And let's go way back up north to Oulu, Finland. There's Oulu. Also a slight downtick over the past 30 days. You can expect an increased downtick in cosmic ray flux, as again, we are not at solar maximum yet. So it's a long way to go to solar maximum, probably over a year, actually. So expect cosmic ray flux to decrease and sunspot number to increase. They always do. Let's talk about energetic particles. We don't have any. So we did have some C-class flares here, but no solar proton events. One of those was a long duration. So the three major events in the past 24 hours are just C-class flares, a C2.8, a C3.0, and a C2.5 approximately. So that's it. And here are the views from SDO. So there is 94 angstroms for the past 24 hours. And the west side has lit up now. So a couple days ago, we were talking about flares most likely on the east side. Now flares are most likely on the west side, especially the northwest. The other optimal view for solar flare observation is 131 angstroms. Another 24-hour video here from Solar Dynamics Observatory. So those C flares all came from the western longitudes. And let's take a look at what's going on overhead before we talk about those CMEs and show you those in great detail. So, did anybody catch the supermoon, the super blue moon? It's just setting right now over Lehigh Valley, Pennsylvania. Also, Venus will be showing up in your morning sky, the second and third brightest objects visible from the planet. Both visible at the moment over Lehigh Valley. That's where we're located, by the way. That's why we show that star chart. You can make your own at skyandtelescope.org to see what's going on over your head. Next, we like to do a solar system forecast. This is what's going on as far as heavenly bodies. Let's advance this 1 week. That's where things will be on the 7th. And again, expecting a CME impact on the 3rd. We'll tell you why here in a moment. First, the astronomy picture of the day, which is not, I'm not really that impressed by this, folks. I am impressed by SpaceX, but this is not a very good astronomy picture of the day. So you may think that this is some sort of a distant galactic nebula or something, and it's not at all. It's SpaceX Crew 7, shortly after rocket separation there. That is rocket plasma. You can see the exhaust there in the middle. That's the astronomy picture of the day at apod.nasa.gov. So, yeah. SpaceX Crew 7 mission. That is 2 minutes after the launch of the Falcon 9 rocket. Anyway, let's talk coronal mass ejections. So late in the day yesterday, right around midnight, you're going to see a CME popping off here. That is the one that is headed toward Earth. It's almost perfectly earthly directed. So that's pretty sweet. That's 106 frames from yesterday, and we should see the aftermath when we move to today's frames. There are an additional, there are the frames from today. Again, you can see the aftermath there, and let's take a look at some more views here. So we've paused this at 2300 approximately. And there you can see that halo eruption. A halo CME is often the sign of an earthly directed coronal mass ejection. So that's exciting stuff, wouldn't you say? We're delighted. That's what's going on. Here's a little better view of Soho Lascaux C2 and C3. You'll see that start to emerge around 2100, I believe. Time and date stamps visible there at the bottom. And here it comes. And it is on the way, folks. Exciting stuff. And we're going to show you stereo A here in a moment first. Actually, let's do stereo A now. So here's stereo A, and I'm just showing it to you to show you that there is insufficient data there. It's not helpful. So let's show our custom coronagraphs instead. And there is Soho Lascaux C2, C3, and SDO 193 angstroms. Exciting stuff. Here's a little closer zoom. And again, it's this plasma filament right here. Part of it will collapse, and part of it will eject. Here's an even closer view. This is just SDO 193 angstroms by itself. One of the many species of ionized iron covered by the Solar Dynamics Observatory. So wait for it. Here goes the filament, and here comes the filament. How you like them apples? Is that sufficient to get you to press like? All right, let's move on to filaments. Yeah, filaments. This is why we monitor them, because sometimes they collapse, sometimes they reposition themselves, and sometimes they eject, and sometimes they do a combination of all three things, which is actually what's happening here, because part of this filament remains intact, part of it collapsed, and part of it is headed toward your doorstep. So that's the El Teide, Spain ground-based hydrogen alpha telescope. Huge filament down here as well. I mean, filaments, filaments, filaments. You can see them. That's why we show them. There's like a dozen nameable filaments on the Earth-facing portion of the solar disk. So don't expect CMEs to stop. Expect CMEs to pick up. And we show the grayscale because it shows prominences as well. You'll be able to see a crown prominence at both poles, and you can expect those to pick up as well in the next year or so as we approach solar maximum. By the way, thanks to our new Twitter followers. Go follow us over there if you are on social media, and if you've unplugged entirely from social media, we don't blame you, because it's pretty pathetic, especially with the disgusting, putrid, criminal state of censorship, rather, on the social media. It's truly putrid. Let's take a look at the past couple of hours here from the GOES 16 SUVI. Massive plasma filaments there in the northeast especially, and a high probability of solar flares getting higher as this sunspot approaches the limb. Next bonus features. First, satellite charging hazards, and we have some minor charging hazards here of the surface charging variety over the eastern Pacific and Mexico. So those surface charging hazards are caused by low-energy electrons. They have a tendency to build up on the outside of spacecraft. Again, those are minor surface charging hazards. The GOES electron flux, kind of low here. And yeah, we did see that little increase in the solar wind density and so on. This is sort of consistent. We've had low electron flux here for a few days. And there is the one-year graph to show you the context of that. Not as low as it gets, but quite low there for the greater than or equal to 2 mega electron volt electron fluence. Here's NOAA's forecast, expecting continued low levels of electron flux. No argument from me there. And let's take a look at the layer of the atmosphere where it's measured, the F layer of the ionosphere, located about 300 kilometers of altitude. Here is the vibrational frequency in megahertz. So that's what's up with the ionosphere. We'll also show the anomalygram because this might be Greek to you. So this will be a little bit more definitive perhaps. The anomaly in megahertz from a 30-day median. And it's for all of you people hoping for doomsday, the ionosphere is not indicating that it's doomsday. So sorry about that. Doomsday is not being forecasted in any way by our channel. Not because of Nibiru, not because of chemtrails, not because of the galaxy being very, very spooky. Nothing like this. Not because of a pole flip. We don't think any of that stuff is dangerous. Here's the latest image. That's 10:15 Universal Time for the ionogram, and there's the anomalygram for the same time. We also show total electron content, which is free electrons to about 12,500 miles of altitude where your GPS satellite is located. And here's our total electron content. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Those free electrons cause signal refraction. And of course, that is what causes your GPS errors. Try turning on Wi-Fi location accuracy if you have Wi-Fi hotspots where you're navigating, because the known locations of those static IP addresses can help you in your navigational accuracy. Total electron content forecast. Next, total electron content anomaly from the 10-day average over North America. Here it is. And it doesn't look like any major anomalies currently going on over North America. We'll close out space weather with the latest intensitygram and latest magnetogram. So there you go. And here's your rock back. Again, the most likely place for a large solar flare at the moment, in my opinion, is the northwestern limb. That would be up here. And let's take a look at Idalia. Idalia moved so fast, folks. I mean, incredibly fast. And it was all because of a bunch of dry, massive air giving it a little push. So we're going to show you that here in a moment. It is now right on the coast of North Carolina. So making incredible headway there. This imagery shows surface winds and mean sea level pressure, barometric pressure. So that's what's going on. Let's take a look at the rest of the relevant air motions. Here are surface winds of the eastern world. Typhoon there now near the coast of Chad. Eke. Here are the jet streams of the east. Here are the jet streams of the central world. Surface winds of the central world. Shout out to our viewers from all around the planet. Surface winds of the west. And there are the jet streams. Remember, folks, understand atmospheric physics, and you too can forecast your own weather. You've got more than enough data to do so. So here's the latest imagery of Idalia as it is now moving off the coast. So it's now moving northeasterly, and it's a big enough system that we have some clouds overhead from it right here in Lehigh Valley, Pennsylvania. How you like them apples? Dag. Moving right along to show clouds and fog over the Americas. For all you weather nerds. Yes. There's the scenario. Shortwave radiation map shows clouds and fog even when it's too dark to use a visible satellite. And that is a moon glow. That white interference you see there, that is the moon. Next, our weather.gov map, and of course you've got tropical storm warnings around the east coast of the U.S. Lots of weather warnings there, also in Hawaii and Alaska. Weather.gov, if you've got weather warnings where you're located, head to weather.gov and click it. Next, how about some forecast? This is the GFS 72-hour pressure and precipitation forecast. Idalia expected to make a turn to the south, but it's going to weaken also. So that's a 72-hour GFS pressure and precipitation forecast. Here is the 72-hour. This is relative humidity and wind. And we're showing you this dry mass of air that gave that system a significant push from behind. So the dry air is depicted there in brown. Remember, folks, dry air at a given atmospheric pressure is more massive than moist air. This is why a low pressure system is associated with moisture and a high pressure system is associated with a clear day. Next, our jet stream forecast, the 250 millibar winds. Jet stream all curled up there over Northern California, driving cold air south and then warm air north. It's going to make it warm in Idaho and cold in California. Last but not least, the temperature anomaly forecast in degrees Celsius for the same period, the GFS 72-hour forecast. Again, understand atmospheric physics, folks, and you can forecast your weather. There is plenty of data. Man, some really hot temperatures coming to the north central U.S. there, like 20 degrees Celsius above normal in about 3 days. We show 72-hour forecasts because they're accurate. And let's do lightning next. There's this current lightning situation. It's about the last 10 hours. And let's pause this, because people are going to say, oh my God, it must be directed energy weapons. Look. Oh, noes. Look at that, folks. That is electrons building up on the outside of spacecraft, probably. Those surface charging hazards that we talked about, yeah, they cause errors in the lightning mapper. That is not directed energy weapons or anything like that. That is erroneous data because of satellite interference. Next, a real-time lightning map. Oh, directed energy weapons, folks. They used lasers. Oh, my God. Yeah, these things have been around since probably the 60s, but certainly the 70s, and they've been widely known about since the 1980s. People found out about them 5 minutes ago, and now they think they're used all the time, even though they have been taken offline, actually. They're not really used, period. Anyway, there's a real-time lightning map from lightningmaps.org. By the way, if you enjoy the content, check out our homepage, smashomash.com. We built a massive web ring for people like you, launched back in February of 2019. So welcome to the Neo Renaissance. Click our links. One of the links you can find there is a link to the Smash Team site. So if you want to support the channel via subscription services, become a member of the Smash Team. There's a bronze level, there's a silver level, there's a gold level, and there's a gold annual paid-up subscription. That's the best value, and you'll find that we're streaming the Go 16 SUVI most of the time there from the Twitch channel. Smashomash.com/SmashTeam. Similar to Patreon, just superior. It's our own site, and it's got greater capabilities than Patreon. Another link you can find on the homepage is to the Hemp Lucid shop. So check out those products. You can help support the channel that way. We've got multiple paid affiliates in an effort to make this channel sustainable. We would prefer to have the videos continue to be publicly visible, free for all to view, and existent. So support the channel via your CBD purchases, if that's something that you're into. Also, get the mushroom gummies, body balms, etc. from our Hemp Lucid link. That is linked both below the video and on the homepage at smashomash.com. Another link you can find is a link to the Amazon shop, which is amazon.com/shop/smashomash. Do you have Eclipse glasses? No? Well, you can get a set of 5 here. Those are the good ones. From our Spacewear collection, amazon.com/shop/smashomash, also linked below the video in the description and on the homepage at smashomash.com. Last but not least is our featured merch item of the day. It is do not pole vault the caldera, folks, because why? Our finest days lie ahead. If you're going through hell, keep going. Civilization is not ending, so don't pole vault the caldera. We don't want you to become part of the lithosphere, as you won't be able to see tomorrow's daily space weather video if you become an igneous rock. So don't pole vault the caldera. If you're going on a volcanic vacation, leave your vault pole at home. This colorful design Features Steve Stimpak, who used to pole vault calderae. Unfortunately, he was killed in a terrible ping pong accident, a table tennis accident there. He was hit by a bus which came through the wall. It's got our YouTube channel and smashomash.com right there on the design. Again, our finest days lie ahead, so don't pole vault the caldera. We'll close this thing out with the latest Doppler radar, clouds and fog. And don't forget to press like and subscribe. The Smash News Network, least busted name in news. So there's the remnant of Idalia, putting an insane amount of rain on Norfolk right now. We've got all kinds of flood warnings around the East Coast. Let's briefly zoom out to show the full 50-state view. There you go. And we're going to focus on the lower 48 view. If you want to look at this yourself, it's radar.weather.gov. There is clouds and fog. Once again, the shortwave radiation map. And there is water vapor. You can see all that dry air providing the impulse that we talked about earlier to push that thing as quickly as it moved. Here's your recap. U.S. Doppler radar showing vertical motion of the air column. Shortwave radiation from space-based systems showing shortwave radiation. Yeah, clouds and fog. They emit infrared radiation, folks. Water vapor. It's a very potent greenhouse gas. This is why it stays warmer on cloudy nights and cooler on clear nights, because less infrared radiation is emitted by the clouds overhead. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Again, CME impact forecast here sometime after midday on September 3rd. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.